How do you use BS9999? Well, I'm going to go through the process with you now. The first thing you need to do is determine the risk profile. So you get that from the tables or you create it. If it's an A1 and A2, you need to get your risk profile. Then you can either use additional measures or you can design using the minimum measures. What might you try first? You might try and get away with the minimum measures. Right, what you ask yourself is, can the minimum measures be provided? Now, if you can't meet the minimum measures, you can't use the code. You need to consider an alternative approach. However, this is not the case for listed buildings. If it's a listed building, you can still progress, but you must show any shortfalls are being covered by some other area. So the code does let you progress with listed buildings if that's the reason you can't meet the minimum. Now, if you can't meet the minimum of BS9999, you won't meet the minimum for ADB. In other words, it's a very, very similar requirement. So that should generally be a yes. So first of all, you need to determine the number of people for each room, the travel distances, the widths of doors, corridors. Does it comply with the means of escape? For example, you might be wanting to push the code and get about 55 metres for example, a shop. And you go into the table, the travel distances with the minimum measures might say 45 metres. You need 55. In other words, you can't meet that travel distance. You can't meet the criteria for the means of escape with the minimum. You need to put in some more. So now you're asking for flexibility. Now this code is allowed to be flexible, and what it says is you can vary it in 3 ways. First of all, you can put sprinklers in. Now, if you put sprinklers in, it reduces the risk profile by a factor of 1. An A3 becomes an A2. An A2 becomes an A1. A B3 becomes a B2. That's the first thing you can do. The next thing you can do is you can put early warning in, or you can have a high ceiling. These are the 3 things. You can do 1, 2, or all of them. And when you've done that, you ask yourself the same thing. Now can I meet the means of escape criteria? Now can I meet the travel distances? Now, say for example, you're trying to push this code a bit too far. You're trying to get an 87 metre travel distance in a shop. You put sprinklers in, you put early warning, and you increase the ceiling height. However, then you go to the tables in the code, the travel distances with the additional measures, you look at the table and it says, shop with sprinklers and all this in, you can't get more than 75 metres. In other words, do you understand? You've gone outside the scope of the code. Now, who do you need to employ? You either employ a fire engineer or you change the design criteria. You've gone outside the scope. You've gone outside the scope. Now, if you can't, you consider an alternative approach. But if you can, you ask yourself, does it comply with the construction and firefighting requirements? If it does, okay, you've met the code. If it doesn't, you upgrade those provisions to meet those requirements. This is how you use BS9999. Does it look particularly complex? No. Does it need to be used by a fire engineer? No. It's be designed for non-specialists such as general architects and designers. This is how you use BS9999. Next area is the variation of guidance. How can you vary the code? Now, the travel distances, door, stair and corridor widths can be altered by the provision of additional features. So what can you do? You can put in sprinklers, you can increase the ceiling height, or you can have an additional level of warning. They're the 3 ways this code will vary. Now, the travel speeds used in the code, because since no evacuation is perfect and human behaviour can be a bit unpredictable, they did use relatively slow travel speeds were used to provide a margin of error. In other words, they did use slow travel speeds. What they decided was risk profile A was 0.4 metres a second and the other risk categories were 0.3. Why? Does that mean that a sprinter in a shop can run faster than you in your office? It's a bit of a... No, it's not based on that. It takes into account thinking time. That's why they use different travel speeds for the human behaviour element. In other words, the general public generally will take longer to react than people in offices. That's why they use different speeds. Now, these are very conservative speeds, but they do allow longer travel distances than at present. Now, in spaces where the density of occupants is low, in other words, where you've got at least 4 square metres per person, the time taken to leave the space is dependent on the travel distance. Whereas in a more crowded space, the determinant is the queuing time. In other words, when you get to the door, you've still got to queue. What this basically says is low density, straight out the door. High density, they've got a queue. The result, low occupancy densities will be allowed longer travel distances. Now, the fire safety measures. Each risk profile has a minimum set of measures. So an A2 or B2 will tell you you've got to have an adequate alarm system, means of escape, etc. Now, first of all occupancies must have an adequate fire alarm. So maybe an A2 risk profile will have a manual. A C risk profile will require smoke detection. Now, as an example about an adequate fire alarm, I went to a council building, 3-storey council building. I'm walking around with the manager, 3-storey, big occupancy. I looked on the wall, there's a rotary bell. You know the bells that you go ding, 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 ding. And I said to this guy, I said, that's not the alarm for this building, surely. He said, of course it isn't. We've got loads of them. They had 8 rotary bells, 1 on every floor, on every exit. I said, you can't have that. He said, and procedures. He got the procedures out. He said, if you discover a fire, you ring your bell. Ding, ding, ding. He said, anybody in the building hearing a bell ringing is to ring their bell. Would you tick that off as an adequate fire alarm system? No, it needs at least a manual break glass system. He had to update it. Each risk profile has a minimum set of measures. For example, some occupancies need smoke detection, like hotels. Sleeping risk needs smoke detection. Again, I was in a library, walking around this manager. Big library, I looked up, I said to him, what are those up there? He said, oh, they are those new, very sensitive smoke detectors. They are the new photothermal detectors. They are the pink smoke detectors. I said, no, they're not, mate. They're covers on the smoke detectors. He said, no, I'm sure they're those new sensitive ones. I said, trust me, mate, they're covers on the smoke detectors. How long have they been there for? 3 months. Contractors have been working, they've covered them over, and they've left them there. And this manager thought they were new pink smoke detectors. Generally, smoke detectors come in one colour, white. Escape lighting. Some buildings need escape lighting. Has that changed in the standard? No. It'll send you to the appropriate British standard. Exit route signage, has that changed? No. BS hasn't changed everything. It's just updated everything to reflect the risk. Exit route signage, what do all signs have to have? Yeah? People say it's the running man. No. You're not supposed to call it the running man anymore. You know that, don't you? In the fire brigade, we were told off on that. Someone said to me, why is it a man? We said, it looks like a man. No, it doesn't. All right, then we'll call it a running person. No, you shouldn't tell people to run in a fire situation. They are called moving person signs. Signage for BS9999 will send you to the appropriate British standard. Now let's look at the maximum allowable travel distances with the minimum measures. This is without taking into account ceiling height sprinklers or additional level of warning. This is the basic starting point. Table 12 here shows you that an A2 risk profile starts off travel distances of 55 metres and 22. So a typical office starts off 55 metres and 22. What is ADB? Well, ADB is 45 and 18. What that means is, if you're designing an office to BS9999, you can start off with an increased travel distance of 10 metres over ADB on the two-way and 4 metres on the dead end. Now, would you agree that most offices now have smoke detection as a norm? They put it in as a norm for property protection, yes. Well, that's definitely an additional means of warning. In other words, with that, using BS9999, you can increase the travel distance to 62 metres and 24. You can increase the travel distance by about 17 metres by using BS9999 instead of approved document B. Why are you using approved document B to design your office when this code will allow you to significantly increase the travel distances based on the risk profile, and that's with the minimum measures, and you put in the early warning anyway? That's what I'm trying to say to you. Why are you using ADB when this code is taking into account the risk profile? And what this implies here, this 55 metres implies that ADB is a bit possibly over the top. That's all it implies. This code allows you to extend travel distances. As I said before, the variation of the code, you can vary the travel distances by putting sprinklers in, additional warning and high ceilings. Also, you've also got to take into account alcohol. A new provision has been brought in here, in line, where the premises contain provision for the consumption of alcoholic beverages, then a reduction in the travel distances of 25% might be advisable for those particular parts. That's something that's been brought in the code. What they're saying is people obviously drunk, they're walking around, the reactions are slower. You might want to extend the travel distances by 25%. How often do I think that's going to get applied? Well, I don't think it's very often. A lot of times that will not be applied in the code. However, this is there in case. For example, one example is a good example. Fire brigade were in a town, they were saying there's a nightclub there that's offering £10 to get in, and you can drink as much as you like. That's the rule. £10 in, drink as much as you like. And the fire brigade are going, whoa, wait there a minute. And the fire brigade are not happy. Because what they're saying is they're thinking now, come 1 o'clock in the morning, everybody in that building is off their head, they're all drunk. If that alarm goes off, no one's going to get out. And the fire brigade have got real concerns about this. And I think in the end, if this is the case, and the fire brigade go down there, in the end they might actually close the place down because it could be deemed to be unsafe. This is the sort of buildings that this is going to be applicable to. This is not applicable to a bowling alley that serves drinks. When was the last time you went to a bowling alley, got that drunk, you started throwing balls at each other? Do people do that? No, they don't get drunk, it's too expensive. In other words, this is not applicable to everywhere alcohol is applied, but it might be applicable in certain areas where the fire brigade and the building control consider that they're thinking that everyone in there is going to be off, basically drunk. Right, smart early warning then. What do you think early warning is a benefit? What percentage do you think early warning is worth? What do you think? Well, I started one seminar. I'll never forget, I went to a seminar, I said, what would you want? If I came to you now, the designer, put early warning, what percentage would you give me? One guy said 100%. Double him. I liked him, I'll definitely use him. He'd sign up 100%. One guy at the front said to me, I'd give you nothing. I said, really give you nothing? I'm going to put early warning in, why can't you allow me to extend the travel distance? He said, no mate, if it says 45 metres in that code, that's all you're getting, I'm not budging. I said, when do you go on holiday? Are you busy? He had no flexibility. Different people give different percentages. And people are doing this now. Some give 10, some give 20. What this code does is it clarifies what you can give safely. It clarifies what you can... It'll help you sleep at night. Some people would not vary travel distances because they're scared. They're scared in case somebody dies in there, then accountable. It gives you 15%. Where a clear benefit resulting from the addition of detection and warning systems is demonstrated and is appropriate to the circumstances, a 15% increase in allowable travel distances and a 15% reduction in both door width, corridor width and stair width can be applied. 15%. Now, is it only worth 15%, do you think? When they work this out, do you think it came out as 15%? Because I don't. I reckon on all the calculations they did, it came out about 30. And what do they always do? Put a factor of safety in. So it's worth at least 30%. So if you as a building controller allow someone to extend the travel distances by 15%, what have you actually given them in benefit? 30. You allow them 15, but it's actually worth 30. That building's safer with that benefit than it was before. Do you understand? They've built in the factor of safety there. What is the benefit of smoke detection or early warning though? People say to me, all right, I've got an L3 system, I've put L2 in, I want 15% extension. No, that's not the idea. Ultimately, building control or approved inspectors have to be persuaded that it's worth it. What they might say to you is, where are you going to put the warning? I'm going to put it in these 3 offices here and I want to extend the travel distances throughout the building. No, I want to see AFD, there. Do you understand? It's a bit of a, it's not straightforward, L3, L2, you get the 15%. You have to demonstrate that it is appropriate to the circumstances. Now, if the building control say to you, I'm not happy, I'm not giving you 15% where it is, what I'd say to them is, where would you like us to see this smoke detection then? Where do you want it? In other words, I want to get the 15% extension with travel distances, where would you like us to put this? In other words, it's a bit of an L5 system, a bit of an engineered solution. That's when you get the benefit. Ultimately, building controller, approved inspector will agree or not agree whether or not 15% is a benefit. What about ceiling height then? What do you think a 10 metre ceiling height is worth in extension to travel distances? What do you think 10 metre ceiling height? Well, the answer is 30%. Now, is it worth 30%? Is that all it's worth? 30%? No. I reckon when they worked it out, it'd come out at 60%, and in the end, they dropped it down to 30%. In other words, it's possibly worth more. All I'm pointing out to you is, and they interpolated it. As you can see on this table here, between 3 to 4 metres, you can get a 5% extension of your travel distance. Between 4 to 5, you get 10%. It's interpolated. In other words, you've got more time to get out. The assumed safe egress time is extended by having a high ceiling. Now, if you need 5% extension in travel distances to negate the requirement for a staircase, if you increase the ceiling height to 3 metres and 1 millimetre, which is what people are going to do, you can get that benefit. Is that wrong? Is that wrong going, I'll make it 3 metres and 1 millimetre? Not really. Meets the code. And people aren't going to... You'll never ever find a ceiling height 3 metres and 90 mil. You'll never get that. It'll all be 3 metres and 1 mil, 4 metres and 1 mil, because it gives you the extra benefit. Now, what travel distances can you get with additional benefits? Table 17 here shows you with an A2 risk profile, which is a typical office, with the additional benefits, with no sprinklers, you can get a 75 metre travel distance two-way and a 24 metre dead end. If you put sprinklers in that office, you can get 90 metres two-way and a 30 metre dead end. That's how far the code can go. Low risk profiles, 90 and 30. What is ADB? 45 and 18. You can effectively double the travel distances in a sprinklered office using BS9999 without compromising life safety. Are you telling me you're not interested in this standard? That is massive. I'll tell you what, a fire engineer submitting a design, trying to double the travel distances at the moment, building control go, whoa, no. That is how far the code goes with safety. Now, to determine these, they used an algorithmic method. That was applied, an algorithmic method. Have a guess what approximately the maximum alternative travel distance, safe travel distance was in an A1 risk profile. Have a guess. Not 90, 155 metres. Whoa. Factor of safety knocked it down to 90. What about dead end? What do you think a safe dead end is in a sprinklered office with a high ceiling and an early warning? 50 metres. That is actually safe. You're walking away from a fire that's out. Sprinklers have put it out. In other words, that's actually safe. 50 metre dead end. And then again, whoa, no further than 30. Now, a good example here, I went to America, and I was in America, and I had a presentation for the fire service in America. And I was talking about BS9999. They wanted to know about this risk-based approach, this performance-based code. And when I mentioned that, it turns out in America, the NFPA codes, you can't get more than 7.5 metres in a dead end. 7.5 metres, that's it, whatever you do. Over here, we get 30. I said, well, someone's got it wrong, haven't they? We've got sprinklers in here, we can get 30, you're allowed 7.5. It's a bit of an inconsistency approach there, isn't it? Now, what does BS99 result in? You apply BS9999, it results in an increase in net floor area for your client. And that's what they want of you, increase in net floor area. I mean, it's that critical. I was in London, a guy was telling me, building controls, walking around with the architect, he said to him, why have you put all the skirting boards in the wall? You know, the skirting boards weren't flush, they were all set into the wall. And this architect said, hey, half an inch. Half an inch. What do you mean half an inch? Half an inch, length of the wall, 50 stories high, it gives you an increase in net floor area. There's architects out there setting skirting boards in walls to get half an inch. There's a code that will allow you to extend the travel distances to 90 metres and 30 in the dead end, and they're not even using it. Where's the logic in that? Where's the logic in that? This code should be used by all architects. All architects. Now, what about aggregate exit widths available then? You know, when you're designing your building, you might have to you've got to work out what available aggregate exit width you've got having different occupancies. Now, if you've got a bar with 2,334 people, a large bar, approved document B will require 11,670 mil available aggregate exit width in that bar. So you need about 11.5 metres of available aggregate exit width after you've taken out the biggest. BS9999 in a bar, take into account other measures, you can get it to 7729. In other words, the same bar, you can have 77 metres of aggregate exit width that will get out those people. That's what this code demonstrates. What does it result in? Well, it results in an increased available floor space or an increase in the licence. Now, this is going to cause problems because the licensing people need to be appreciative of this. What it means is, if I've got a bar and I've got AFD, high ceiling, whatever I've got, I work it out, I need 7 metres of aggregate exit width. Well, if ADB says you need 11, and they're basing it on ADB, they'll give you a licence for 500 people, whatever. Or, in this case, 2,334 people with BS9999. All I'm pointing out is, do you understand the implication of the licence? If you use BS9999, you can effectively increase the licence in that bar because you've demonstrated they can all get out. And my brother's an architect, he said to me, you can't do that. Wait there, you can't do that. They won't accept that. Well, they'll have to in a way because you've demonstrated they can get out. If I've got 7,729 mil of available aggregate exit width in that bar, I can get 2,334 people out. That's how it works. However, you understand the implications. Is BS9999 just for larger developments? No. Any bar, any licensed premise, you want to look at this code. Because effectively what you're doing is you're demonstrating with the additional benefits that they can get out. And it's not compromising life safety, it's using fire engineered principles. What about a shop? A shop with 1,728 people in, ADB will require approximately 8,640 mil of available aggregate exit width to get them out. BS9999, especially if it's sprinklered, with early warning, high ceilings, etc., you can get it down to 5722. Is BS9999 just for larger developments? No. Any shop out there, especially sprinklered, you want to look at this code. It's a B2 risk profile. You want to look at this code because it's going to design a much better design for your client. Much better design. What about the stair widths then? This is an example. I mean, this is just an example picked out. 875 people, 4 floors served. Very busy shop. Your stair widths are nearly 4 metres. Just standard 4 metres. That's without taking into account lobby approach. Just an example, it'd be 4 metres. Have a guess what BS9999 would say that staircase width would be with sprinklers. Now ADB, if it was 4 metres, even with sprinklers it's still 4 metres. Have a guess what it would be just by putting sprinklers in. Well, I'll tell you now, it would change to 1859. That is the impact of putting sprinklers in a shop on the stair width of that particular stair. That's without lobbying it. Why? Because BS9999 understands the importance of sprinklers, it reduces the risk profile, and it also says if sprinklers are installed, the stair discounting process does not apply. The implications to you are, if you've got a shop, don't lobby it to make them narrower, take into account sprinklers, and you can effectively halve the size of the staircase by putting sprinklers in. And if you put early warning in that shop, you can get it down to 1581. Do you understand how important this code is to your design? And what's that? Look at the size of the staircase, 1581, and BS9999 ADB is 4 metres. That's without lobbying it. Do you understand how important this code is? Question, is BS9999 just for larger developments? No, it's for all buildings. Will architects be interested in this standard? Of course they will. In a competitive market, this code is the most significant change in fire legislation. All architects, designers do need to look at this code. It's got significant benefits, and if you don't, you could lose a lot of your clients.